The slope fields do kind of look crazy. It's one of those things like what is it? What does it do? Just kind of like what is it? So what a slope field is a direction field, right? Isn't slope another words for like direction? Increasing, decreasing, right? If you have a slope of +2, it means you're increasing 2 units for every 1 unit over, right? It's a direction, right? Slope is always a direction. Y-intercept is kind of the starting point, and then the slope is the direction to get to your next point, right? That's why they call it a directional field, okay? It's on a graph. You're not going to be given special graphs. They put dots on there because it's a little easier to read. Sometimes when it's just graph paper, it's hard to read, okay? But it kind of looks weird because of the graph, because of the dots. Don't worry about that. The dots are the same thing as a regular graph paper. Just they do dots for slope fields just because it's easier to read with dots, okay? So what a slope field is a field or graph of slopes, directions, okay? So if I look at any point, we've spent last semester, right, doing this, right? Find the derivative of a function and then tell me the slope when x equals whatever, right? You find the derivative, you plug it in, and you say at that point, slope is whatever, positive, negative, whatever it is, right? That's essentially what a slope field is. It's just, it tells you where all of the slopes are at all of the points as opposed to just one, okay? So, for example, so differential, so the slope is 2y. So that's the slope for this function here. Don't know what the original is, we'll find that out later. But for right now, we have 2y. So for example, if I wanted to find the slope at 0, 0, so the origin. If I wanted to find the slope at 0, 0, what would I do? Think last semester. What did we do when we wanted to find the slope at a given point? What did we do? Plug in x to the derivative, right? Got a number, that was it. That's what we're doing today. So if this is the derivative at 0, what would the slope be? So this point is 0, 0, right? So dy over dx, and I'm looking at 0, 0, right? So now instead of an x, we get an x and a y. But it's the same idea, plug it in, right? So we plug in 0 for y. We have nowhere to plug in x. Sometimes that'll be the case. Okay, so we're not going to plug in x because there is no x. We get 0. So that means the slope at 0, 0.
Can we plug in -1? That's the next question.
What?
That's the next question. Oh.
Yeah, I'm on A. I'm on question A right now. So at 0, 0, the slope is also 0.
Okay.
So what would a slope of 0 look like?
Straight line.
Straight line. Gotta help me out with a straight line because straight line can look different ways. Horizontal straight line, yeah. So we're gonna draw a little segment that kind of looks like that. So that tells me if I'm reading this graph that at 0, 0, this function is going to have a direction or slope of 0. Okay. Let's go up one. Let's go here. 0, 1. So we say dy over dx for the same, it's the same function. Oops. So for 0, 1, right? What would we plug in for y at 0, 1? 1. So it would have a slope of 2. So at that point, I'm going to draw a little segment with a slope of 2, best I can. So slope of 2 means you got to go up 2 over 1. So it's got to have this direction. So I'm going to draw a little segment with that direction best I can. Okay. Do I know it's 2 exactly? No, but I know it's positive, right? You just try to draw it the best you can.
That's 4.
Okay. So now let's go over 1 to 1, 0. dy over dx, 0, 1. Or sorry, 1, 0, not 0, 1, 1, 0. What would the slope be at 1, 0? 0, because 2 times 0 is 0. So over here, I would draw a 0 slope. Now save yourself some time so you don't have to do all the points. Where else would be a 0 slope?
X equals 0. No, y equals 0.
Anywhere y equals 0, right? Anywhere y equals 0. What's another place, what's another name for something we call when y equals 0? What's x-axis? It's the x-axis. So all along the x-axis, I'm going to have 0 slopes. At 0, 1, I had a 2 slope. Is there anywhere else I'm going to have a positive 2 slope? Anywhere y equals 1, right? So where else does y equal 1? All along that horizontal line. So all along that horizontal line, we're going to draw the same direction.
All right, follow.
Okay. Now let's go up. What is the slope going to be when y equals 2? 4. So it's going to be a little steeper than that, right? Because 4 means up 4 units over 1 unit, right? So it's got to be pretty steep. So we're going to try to do that the best we can. It's kind of hard because it's just little segments, but we want to kind of draw them. We definitely want to match them. All of these guys we want to match. And we want to show it's going to be positive. Okay? So you can tell as I'm going up in the y's, I'm getting a bigger slope, right? A bigger slope. Okay? All right, so now let's go down to the where y equals -1. Where y equals -1, what is the slope going to be? -2. So we're going to draw something that's perpendicular to these guys. Okay, perpendicular, so -2. Draw it the best you can, little segments. And then what is the, at -2, when y is -2, what's the -4, right? Mm-hmm. And that's a slope field. So when you look at a graph that kind of has these marks, it's a graph of all the slopes. Now, can you look at a graph and tell exactly that's -2, that's -4? No, no, you can't. But you can at least tell the direction. That's why it's called the direction field. Okay? Slope field, maybe not the best term because I can't tell exactly what the slope is just by looking at it, but I can tell direction, right? I can tell direction. Okay? So letter B says, suppose that the point 0, -1. So 0, -1 is right. So 0, -1, 0, down 1, right here. That point right there. So suppose that point is on the particular solution. We know that word. We've seen that with that phrase before, right? Particular solution of the differential equation above. By following the slopes, draw on the diagram what you think the particular solution will look like. Okay, so we're going to draw what it looks like. That's the thing about the direction fields. We're just going to go with the flow. If I go to the right, if I move that dot, that green dot to the right, which way the direction field's going to pull it? Am I going to be able to go straight across? No, because which way the direction field's telling me to go?
-2.
Down. They're telling me to go down, right? They're telling me I can't go across, I can't go against the direction fields. I have to go where the direction fields tell me. So I can't go that way because it's telling me I need to be having a slope of -2. So it's going to kind of be like that. I'm going to kind of have to go down that way. Okay, that's one way. I'm going to do it for the other way right now. So, go in that direction. So what if I went the other direction? What if I went to the left? Would I go straight across? Would I go down? Would I go up? Where would I go? I'd go up, right? Would I keep going up? So would I keep going up like that? No, I broke one of the, I can't cross the x-axis because the x-axis says there, you're going horizontal. So I would start going up, like you guys said. I would definitely start going in the up direction, but then I would kind of top off at y = 0. So it's got to kind of that direction. Okay? Now what you guys did on practice 10 was come up with the equation of that I just drew. The equation of, this is the particular solution. So if I knew the equation to this guy, which we're going to do here in a second, letter C, we're going to do that. That would be the particular solution. So essentially we've been doing this just analytically. Now we're going to do it graphically. Okay, so now part C says, do what you've been doing on practice 10. Okay, so this is one of the easy ones. You're lucky they give you an easy one on this one. How would I solve by separating this guy here? Divide by y, right? So you would get 1y dy equals 2 dx, right? Because you'd separate the variables, divide both sides by y, multiply both sides by dx. And then the second step said, do your antiderivative. What's the antiderivative of 1 over y? Natural log of y. I'm going to use brackets because I don't know what I'm plugging in yet, because it's always got to be positive. And the antiderivative of 2 is just 2x, right? Plus c, right? Remember that plus c, because there's no balance. And then we plugged in the point, right? We plugged in, so here's the point here. The same point we started at. So we're going to plug in 0 for x and -1 for y. So when I plug in -1, it's actually going to become +1. So it's actually going to be natural log of 1 equals 0 plus c. Well, what is the natural log of 1? What is log of 1 at all? 1. Or sorry, 0, right? Log, anytime you have a log of 1, natural log, regular log, it's always 0. Okay, so let's go back here. The natural log of y equals 2x plus 0. That's what you've been doing. That was the last lesson, right? That was the last lesson earlier in this packet, which you did the practice yesterday. Okay, now what I have to do here is solve for y. How am I going to solve for y now? How do I solve this guy for y? Change it to an exponent, right? Right now, 2x, right? It's really log with a base of e equals 2x. So you're going to have e to that power equals that. Okay. So it really is going to be y equals e to the 2x.
Yeah, that's about right.
This guy and that guy are the same thing.
That looks about right.
Okay. These two guys are exactly the same thing. So you've been doing this process, you've just been doing it using separation of variables. Now we're just giving you another way of doing it. Okay. All right. Okay, so what I want you to do now is try an example. Try A. Sketch. It's a smaller graph. Sketch, so give me the direction field for this guy. Okay? It's a new equation with an x as well as a y. Okay, so do A, and then we'll do B together.
Which is why.
Look for patterns when you're doing a direction or slope field. Look for patterns because it'll cut down on the work.
0, 1.
So it's 0.
0, 1, 0. So flat 9.
So from 2, toss it that way.
That's a 1.
All right. What does an undefined slope look like? Vertical line. Yeah.
Oh, yeah.
So like for 0, 0, I got one. It just looks like a vertical line. That's okay. And then you think to yourself, why is it undefined? What causes the undefined? 0 on the bottom, right? What other values could I plug in that would also give me 0 on the bottom? Anywhere y equals 0, right? Anytime I'm plugging in 0 for y. Saves you time. Now you don't have to do these dots because there will always be patterns. Is there going to be a lot of patterns? Sometimes there's a lot, sometimes there's not. But there's always going to be patterns so that you don't have to calculate this for every single dot. Okay, use those patterns. When am I going to get a slope of 0? When the top is 0, right?
And the bottom is something.
The bottom has to be something, right? So that means to make the top equal to 0, isn't that a 1? A 1 minus 1? So when x is 1, but y has to be something other than 0, right?
0 over 0 undefined.
That's a great question. That's a great question. I'm going to have to Google that because I don't know.
No, it's not. I'm silly.
So I'll give you a hint. It's not about the slope fields. Look at the functions themselves. What do you notice about these guys that doesn't jive when I say slope fields? Doesn't make sense when I say slope fields. What do you need to do a slope field? What do you need? A differential equation, right? Are any of these differential equations? No. Right? How do we know there's no prime? It should be y prime, right? These should all be y prime. So matching them to this is going to be hard because you don't have derivatives. So the first thing you got to do is find the derivative of each, okay? They're not hard functions, but you got to find derivatives first. To do a slope field or to match a slope field or any of those things, you need a slope, right? And we don't have any slopes right now. So let's go through and find the slopes. So the slope of A, what's the slope of 1? 0. What's the slope of x squared? 2x. What's the slope of regular x? It's 1, right? Okay, let's see if you can do these in your head. What's the slope of 1/3 x cubed? X squared. What's the slope of sine? Cosine. What's the slope of natural log?
1 over
1
x.
over x. What's the slope of cosine? Negative sine. Good. So this one is not hard, but this one you might need to do some, I skipped this one because this one you probably need to do a little bit of this to do it. So then you'd get negative 2x to the negative 3, which is negative 2x cubed. So it's not as easy to do in your head. Okay. That's why I left that one for last, because. Okay, so let's go through. Let's look at number 1. So look at number 1. What patterns do you notice with number 1? Everywhere this happens, this happens. Everywhere this happens, this happens. Or everywhere this happens, this doesn't happen. That's a pattern. So I don't want to know one point. I want to know in this area, this always happens. That's the kind of thing I want to look at. So what do you notice? In what area, what happens all the time? It's on the y-axis. It's always, looks like a positive 1 maybe. It's always the same. Definitely always the same, right? On the y-axis, it's always the same. Maybe positive 1, maybe 1/2, 2. I don't know exactly, but it's always going to be the same positive derivative, right? That's good. What else do we notice about it?
On both 2's negative and positive, it appears to be going down.
So when 2 is x is 2, they're going down.
And on negative 2, it's also going down.
Negative 2 is going down. Good. Look up and down. Up and down. The y's. Isn't it always the same x? Always the same slope?
Yeah.
Same direction, I should say.
Looks about.
Like this guy all have the same slope. This guy all have the same slope. This guy all have the same slope. This guy. And does the pattern look familiar at all when you're kind of going with the flow? Looks like a trig function, right? It increases, decreases, right? Starts decreasing, then increases, then decreases. So it's either going to be sine or cosine, right? So it's either going to be G or F. Okay? So let's talk about, let's go F. We're going to use we're using the differential equations now. Okay? So at 0, when x is 0, what is the slope for this guy here? 1, right? Positive 1? Does this look like a positive 1? It does. It does look like a positive 1, right? So let's go over here. When x is 1, what's the slope? 0. These guys do not look like zeros, right? So leading me to think that this is going to be the answer, but let's keep going. When, so I don't know, they don't really tell us, but pi over 2 or pi. So as I get bigger in the x direction, it goes up and then goes down for both of them, right? Isn't that how sine and cosine work?
Yeah.
Except not this guy here. Which direction is this guy going to start out as? Yeah, it's going to mirror, right? Cosine usually starts like this and goes like this, right? Negative means it's going to go the opposite direction, right? So that one doesn't match what it's doing. So that gives me further evidence to show that this guy is letter F. Okay. Look for patterns. Look for patterns. Okay, how about 2? Roman numeral number 2. What patterns do you see? Everywhere this happens, this happens.
Y is 0.
Everywhere, not y is 0, x is 0. When x is 0, what's always the case?
Slope is 0.
Slope of 0, right? So when x is 0, the slope is going to be 0. So let's go through and see if we can get rid of these. So this one, we know f, we're good. Okay, so how about the first one? Does that make sense? Does it jive with the first one, A? Would I have a slope of 0?
Yeah.
Yeah, it's going to be 0 everywhere, right? Doesn't this guy say it's going to be 0 everywhere?
Yeah.
Does this have 0 everywhere?
No.
No. So we can cross that one out.
Darn.
Okay. B. Let's look at letter B. Can letter B, would it have a slope of 0 anywhere? No, only one, right? Okay. C. When x is 0, will it have a slope of 0? Yeah. Okay, so we'll keep that one. I'm not going to get that one yet, but it's definitely not going to get crossed out. How about D? When I have x equals 0, would that have slope of 0? Yeah, so that one's a possibility. We'll keep that one there too. E, how about E? When I have x equals 0, would that have a slope of 0? No, it's undefined, right? It would be undefined. No. This guy here. Trig function, if I had, when x is 0, that would have a slope of 0, because sine of 0 is 0, so, okay, we'll keep that one. How about y, or sorry, h? No, undefined, right? Another undefined. Okay, so now we whittle it down to 3. Okay, let's keep going. What else do we notice? Everywhere that x equals, looks like everywhere that x equals +1 or -1, what's
The slope looks like a 1.
the slope looks like about 1. About 1, right? It's positive, definitely positive though. So anytime I plug in a 1 or a -1 for x, it's going to give me a positive 1-ish. Okay? So how about C? If I plug in +1 or -1, would it give me positive 1-ish? No. It would give me +2 or -2, right? Cross it off the list. How about D? Right, yeah, because if you plug in +1, +1 squared is 1. If you plug in -1, -1 squared is 1. Good. How about G? Sine of 1 or sine of -1. So 1 would be about, I know it's not in radians, so it's kind of confusing. So 1 would be about pi over 3-ish. Because pi divided by 3 is about 1. That would be, yeah, that would make it negative, right? So that one's not going to work either. Okay. We only got one. It has to be D.
See, I told you, Johnny.
Okay. That's the way I kind of go through them. Okay. All right. So the last thing we're going to do is I want you to do, there's 6 graphs, 6, they're already differential, so you don't have to find the derivative. That's already been done for you, okay? Each one is only going to be used once, and every one of them has to be used. So if you say A goes with 1, then 1 can't go with anybody else. Okay, make sense? Okay. So I'll give you some time. I'll give you about 10 minutes or so, and then we'll go over it. I start. Doesn't mean you have to do it this way, but after all the years of doing it, this is the way I start. I find the graphs are a little bit, there's a lot going on with the graphs. So what I do is I start with the differentials. And I want to notice in my head, anytime I plug in this value happens. So like for example, look at Roman numeral number 1. Is there going to be, it's an exponential. If I plug in a negative number, am I ever going to get a negative answer? No. I could plug in a positive number, a negative number, anything in there. It'll always be positive, right? So which graph only has positive slopes? There's only one, and it's F. F only has positive slopes. Every other of them has negative slopes somewhere, right? So we're going to go 1F. Roman numeral 1. And then I look at, okay, so let me see, let me cross that one out since we're done with that one. Okay, next one. Y is on the bottom. So that means anytime Y is 0, what's always going to happen? It's going to be like that, right? So let's look. Definitely not A. Definitely not B, that's 0. C, I can't really tell. Definitely not D. Definitely not E. It's looking like C might be the best, but I'm not sure yet, so I'm not ready to give that answer. Okay? Let's look at number 3. Anytime I plug in this value, I'm always going to get what number? To number 3. For Y, right? Every time I plug in 2 for Y, I'm always going to get 0. So let's go. Where do I have a graph when everywhere is Y is going to be flatlined? A, right? Everywhere Y is 2, it's straight. So that one we know for sure. So that one we can do Roman numeral 3. Letter 4. X runs the show, right? Y has no say in anything because there is no Y. Y has no say in anything. So anytime I plug in an X, that's going to be the slope field, right? That's going to be the slope. So when X is 0, it's going to be horizontal. When X is 1, it's going to be horizontal all the way. When X is 2, or sorry, not horizontal, positive, positive, positive. Yeah. When X is negative, it's always going to be negative, right? Yeah. Which one matches that? B. B. Okay, that's 4. Good. Roman numeral 5. When X and Y cancel each other out, what am I going to get? 0. So when X and Y are exactly the same number, I'm going to have a 0 slope. That one matches letter E, right? Kind of looks like a step. 1, 1, 2, 2, 3, 3, 4, 4, negative 1, negative 1, negative 2, negative 2, right? Anytime they're exactly the same value, they cancel each other out. So now I'm down to 2 with 2 left. Okay, so sine, what do we know about sine? When is sine 0? 0, right? 0. So we have this guy and this guy. So which guy matches the best? D, right? That means 2 has to be C. Okay? Now, like I said, that's the way I do it. I don't really look at the fields and look at when I'm matching. I look at this and look for patterns. So important that you guys look for patterns when you're doing this because it'll make it so much easier. Okay? So tomorrow we're going to work on the practice. Yep.